Our planet hides immense power beneath its surface, where heat and pressure shape the ground we walk on. Deep in volcanic systems, gold is born, not by chance but through a remarkable journey from molten depths to the Earth's crust. This journey is a complex geological process, a kind of natural alchemy. It all starts with a chamber of magma, the engine that drives superheated mineral-rich water upward. As these fluids rise, they interact with rocks, leaving behind clues, broken ground, strange colors, unique minerals. By reading these signs, we can trace the path of gold. The quest for gold is no longer just luck, it's a science of interpreting the Earth's story. From Nevada's deserts to Indonesia's islands, the principles remain the same. The Earth provides a map, and we must learn to read it. Today, advanced tools like AI-powered mapping systems help us see the Earth in new ways. Yet the core skill is unchanged. Observe, understand, and follow the story the planet tells. The search for gold is an invitation to look closer at the world around us. It's a detective story on a planetary scale, with gold as the prize. Let's follow the journey from the fiery depths to the surface clues that lead to hidden treasure. Every volcanic gold system begins with a heart of fire, a magma chamber miles below the surface. This molten engine heats surrounding rock and draws water deep underground, transforming it into a superheated, mineral-rich fluid. Acting as a powerful solvent, this fluid dissolves rock and picks up trace elements, including gold. Driven by pressure, the fluid rises, leaching gold and other minerals as it moves upward. Over thousands or millions of years, these fluids concentrate gold along their path. The magma chamber is the unseen origin, creating the conditions for gold to form. Geologists map ancient magma chambers now solidified to predict where gold-rich fluids once traveled. By tracing these ancient pathways, we can follow the gold's journey from deep within the Earth. The first step in finding gold is understanding where this powerful engine once operated. The story of gold begins in the depths, but its clues are left behind in the rocks above. The journey upward is just beginning. As mineral-rich fluids rise, they meet resistance from solid rock above. Pressure builds until suddenly the fluid explodes into steam, shattering the rock and creating a breccia pipe, a vertical column of broken rock fragments. These pipes, cemented by minerals, are critical clues for gold hunters. The shattered rock forms a porous pathway, trapping mineral-rich fluids as they continue to rise. As the fluids cool and lose pressure, gold and other minerals precipitate out, filling the spaces between rock fragments. On the surface, breccia pipes appear as chaotic jumbled rocks, often stained red, orange, or yellow by weathered iron minerals. These colorful iron hats are beacons, signaling a mineralized system below. Breccia pipes are not random, they are the main arteries of volcanic plumbing, both pathway and trap for gold. Major gold deposits like Colorado's Cripple Creek are found in these ancient breccia systems. Discovering a breccia pipe means you're directly above the pathways where gold-bearing fluids once surged. For explorers, it's a sign they're in the right place. The next step is to follow the clues deeper. When hot mineral-rich fluids reach the surface, they emerge as hot springs and geysers. As the water cools, dissolved silica forms layered rocks called silica sinter. Terraces seen in places like Yellowstone. Sinter caps are fossilized remains of ancient hot springs, marking where hydrothermal systems once broke the surface. While sinter itself rarely contains much gold, it points to the gold-rich boiling zone just below. Geologists search for these pale, layered outcrops to target exploration beneath them. The sinter is the X that marks the spot. The journey of hot fluids alters the rocks they pass through, leaving behind colorful halos called hydrothermal alteration zones. These zones can stretch for hundreds of feet, forming a chemical footprint around the fluid pathways. Closest to the core, rocks are intensely altered and replaced by silica. Further out, clays and pyrite form, bleaching rocks or staining them red and yellow. These patterns are predictable, like rings around the gold system's core. Mapping alteration zones helps geologists zero in on the hottest, most gold-rich areas. The vivid colors and textures are nature's guideposts. In places like Indonesia's Grasberg mine, these halos are visible from space, a testament to the power of these systems. As hydrothermal fluids rise and cool near the surface, gold and minerals precipitate out, forming epithermal veins. These veins fill cracks in the rock, often as bands of quartz or calcite with tiny, sometimes invisible, particles of gold. The richest gold is found in the boiling zone, a specific depth where pressure drops and gold rapidly precipitates. The surface sinter cap signals a system, the veins below are where the treasure is trapped. Prospectors look for outcrops of quartz veins and signs of mineralization. Banding in the veins reveals multiple pulses of fluid over time. Historic gold rushes like Nevada's Comstock Lode followed these veins deep underground. Understanding these veins as crystallized pathways of ancient fluids is key. They are the logical end of a journey that began in a magma chamber. The real prize lies in reading the veins' story. Finding gold isn't about a single clue. It's about assembling a complete picture from many signs. Modern exploration stacks clues: volcanic rocks, fault lines, geochemical anomalies, alteration zones, sinter caps, breccia pipes, and veins. By layering this data, patterns emerge, revealing the most promising targets. The goal is to find where all the best indicators converge, the likely location of the gold-rich boiling zone. This systematic approach turns exploration from guesswork into science. Drilling is expensive, so narrowing the search is crucial. Geological logic is what separates success from failure. The principles of mapping gold systems are timeless, but today's tools are revolutionary. AI-powered maps process vast datasets, satellite images, geophysics, rock chemistry faster than ever. AI highlights subtle patterns, but it's the geologist who confirms the story on the ground. The synergy of human insight and machine intelligence is the future of discovery. The search for gold is about curiosity, patience, and observation. By reading the language of rocks, we turn luck into logic. The treasure is out there for those who know how to look. The adventure is yours to begin.